Engineering Eng. PDF document of this video is on engineereng.com.
Hello friends, in this video I will show you how to write, call and use a function in MATLAB in a basic and simple way. I want to talk about that. Now I want to show you how to write the function by opening a new file without further ado. The purpose of the function is, friends, like this. When you write any code, you send it to a function on any line that will make your job easier and you get the result directly on that line. This is a useful function. For example, let's simply write the function of an addition. How do we write this? Now let's say you have a function like this. Now, precious, you want to get a result. In this result, you want to see the sum of two numbers. For example, our numbers are 2 and 3. I'll say the sum of these 2 and 3 is solved by a function and brought to me. I get the result as follows, not in the form of 2 plus 3 equals 5. Let me send the numbers I have to a function called add that does addition, and let me add the result. So I want him to bring the result of my operation as the sum of 2 and 3. So whichever two numbers I enter here, you send me their total. Doesn't necessarily total. You can do whatever operation comes to mind. You can write a program that can do it, friends. Now I'm writing the program for this. I will open another script file and write its function here. I will come back to this question later, friends. Now it is written as follows, guys. You say function. You have to write a function here, but what you write after the blank is up to you. Usually y is used. I just determined the name of the function as I send it to the sum function. You must write the name of the function you want to send, but you are still free to choose what you want to write here. If I have written something else here, I had to use it here as well. I named the sum here because I will do the summing process now, because the content sent to collect will come here, guys. Collect works with the following logic. It takes any two variables like a, b. This function has an AND, guys. This way you close and fill this gap. So how do we fill it? The left side of the equation is important to us here. So here is what you should give as output. Since whatever part of the output is on the left side, I have to equate the last y to something. So I need to find the result what will come out as y. Therefore, my result of y that will come out here is the sum of a and b, guys. Normally, there should be numbers in MATLAB, but look, there isn't any numbers here. Why not? Because I will send those numbers a and b here anyway. A function that will automatically perceive the left side of the commas as a, when you send it here, it will perceive the 3 to the right of the comma as b and process with a and b, and it will create the result y and wait. Since this was last posted from here, this will again y itself to replace the entire sum function. Yes. For example, how many come out of here is y. If we send 2 and 3 to add like this, of course it will come out as a 5, which is the sum of 2 and 3. Now let's save this function we wrote. The place we saved is important to us because wherever we save it, we need to work in that area so that MATLAB can pull the function from the working area. Also pay attention to this. Previously untitled names after function y equals automatically MATLAB can detect the name of the function from the first equal sign to the first bracket. Now I record the in the workspace of the lesson 16 like this. Then I went back to my untitled function. More precious, this script. In the script, I'm sending 2 and 3 with collect. And I expect to see the result as 5. Now let's run this too. Of course, he will ask me to save it first. Notice that I save it the same place as the add function in the study area of the 16th lesson. And so let's call it D16 1.1 like that. Let's look at the conclusion. As you can see, it shows our result as 5. Shows us. If I send 2 different numbers, for example 100 to 13, I will get the sum of the 113 this time, guys. Let's make changes on it immediately. Let's use the add function as if it is not multiplying. For example, the product of 100 by 13 will be 1300. I immediately make the plus here. Is multiply symbol, let it A multiply B, and let's save it over again. Then we will run it, the friends do the multiplication. As you can see, it gives the result 1300. Even if I do not change the name, we have also done the multiplication operation in this region, because y gives the output whichever operation you do here. But let's not split it, keep it as a ball for now. Again, let's see 113, which is the result of the addition, and let's move to another example. Let's move to another example that might be useful for you. I would like to give an example about the unit step and ramp functions that can be useful in the signal lesson. Now let's try to write the unit step function first, guys. What was unit step, guys? Our UT function. There are several definitions. This is our t function, guys, ut. This is 0. There are several definitions of this. There is 0 field in 0. 0 has this area of 0.5, but the guess is this. The function is 1 when it's greater than 0 and equal to 0 when it is less than 0. This is the general graphical representation of the ut function. Its representation as a mathematical function, a definition of ut equals to 1, t greater than 0, comma ut equals to 0, and t lower than 0. In another definition, it is shown as follows. It is said that unit step function equals to 0, t lower than 0, 0, ut equals to 0.5, t equals to 1, and ut equals to 1 greater than 0 if t is equals to 1. There's a function definition like this you also know from the signal lesson. Basically, these are the unit step and ramp function. The functions we call ramp are inclined. Now let's write their function and see if we'll write it right. Let's open a new file. So open a new file, create a function file first. And I automatically write the function to this function. I don't have to write y, but usually y is written. And let it be called unit step, meaning a step, u step. Let x array get into the prep function. Let us check your x array. Why will he check? Because the x array it will take will be variable. Is this time axis. It will detect which ones are less than 0 and which are greater than 0 in this time axis. That we will determine whether to assign a value of 0 or a value of 1 to them. I'm going to use this now because the other has 3 variables. I will write a function that I will accept 1 when greater than equals to 0, and I will accept 0 when lower than 0, so that you can see it more comfortable. How do we write this? Now I immediately put the end of the function, prepared the space in between, and try to write my function. There will eventually come one x array here, and x array will come to the unit step. This is not to have to x array amen is sent. I know that the incoming x here will be conditional, so I know it's a value representing the time axis. So how am I going to do this? We'll do it like this, guys. I will open a for loop. I will prepare a place equal to the size of x coming to this function from I equals to 1. So let me have x as many elements as x here. Then I will do this. What do I know, guys? Time axis. If greater and equals to 0 is 1, 0 is lower than 0 if 0. I have to apply. So because I said I have to do if check, I will always check the x's here. I will take the first value of incoming x, that is the first of the incoming x zone. After all, I will start from 1. Let's check the first value of I. As a result of this control process, I said if these values are greater and equals to 0, look, I always equate to the output to give. Let y equals 1 since y will be our output. So what did I write here? If my incoming x array is greater than 0, I said equate your result 1. If something is greater than 0, I don't need to write the else to see if it's less than 0. Numbers that are less than 0 are left to the direct else. So I'm closing it like this. I said else. You can write it right here, but I usually write it under. If the y are less than 0, I say that it is equal to 0. So what will I do this time, guys? First end is the if, the second end is the for, and the last end is the end of our function. In this way we created our function. We have to save it now. Note, while saving it automatically sees the part up to the first bracket to the right of y equals. As you can see, he saw it in the form of, this is how we recorded it, upper floor. Now let's open an integer file and send it to the unit step function. And let's try to get this function. Let's write a function like this here. Again, we are writing our classic commands quickly. I wrote this way and prepare our place. We have an x array like this. Let it be in the form of x equals to -2, -1, 0, 1.1, 1.2, 2, 3. Let's not call this x. Let's not confuse you. We call this x, here was an x, so that you don't have a question mark in your mind as if it had to be an x. Let me make this family. The important thing here is that I have something to send to that function. So my family is ready. Let's see. Now I will get a result and I will send the network to the unit step function. After sending this AR to the unit step function, when the number starting from -2 to 3 come here, the AR will now come to a because it represents x. We will check the A's. I will check if the values of A are greater than 0 or not. For the values of A greater than or equal to 0, I will equate the result of 12. I will set equal to a 0 for others. So when I run this result, I expect to see something like this. How many employees are there? 7. I accept the result of 2, 0 for less than 0 out of 7 elements and 1 for the remaining 5 elements because I equated those greater than 0 to 1 here. So let's see if we can run this and meet our experiment. Let's save it as D16.2 and let's look at the command window, guys. As you can see, for -2 and -1, there is 0 for values less than 0. Since I say equal to 1 for values greater than 0 and 0, we can see the unit step in this way. But an advice from me is that there is a better way to see unit step. Our array doesn't have to be that way. Our array could also be like that. Let's say I got it is integers in the range of a equals to -3, 1, 3. I will start one first, tell you why I made it that way. The other way I am talking about things graphically. There will be a result from here. We can see this incoming result unit step function move more easily in the graph. Will we be able to see this card? My goal is to check if I can see this graph. So here I say plot to see this. I draw the result against the incoming A, and let's see if the result gives me the unit step function as I expected. I want to check this to see if you can see the value 0 from -3 to 0, 1 from 0 to 3. Now I closed that, prepared it that way. Now I closed. Prepared it that way. My unit step function is waiting here. I say run it. Notice that there is no result from -3 to 0. But notice there is an uplift here. The reason for this is, friends, combining the last value with the value up to the last 0 in MATLAB is a plot command. If you want to see this graph here, that is, if we want it to rise an impulse function at exactly 0, we need to increase the number of steps here. That's why I just bought this one, not 0.1. Now when I get my step bigger, I'm hoping to see the direct rise of this function from 0 to 1 over here altogether. Let's close this figure for now. We will try to lose the cross in the figure. Let's see if it will. Look, when we run it, we can clearly see the following functions, guys. We see that between -3 and 3 it starts to take the value 0 from the -3 to 0 and 1 from 0. Of course, the way to see it even more beautiful, when I type line width 2 and the plot command, we can see it better. 2 here means draw 2 times ticker, of course. Yes. I will write another example now. Let's move on the ramp function, guys. By the way, let me say something that will help the signal lesson. If the value that makes it 0 is greater than 0, it starts talking values. Let's draw what you expect if I say A minus 1. For example, what is unit step A minus 1, T minus 1, guys? This time you wait for values that make them 0 and greater than 0. So the values that make 0 inside here started from 0 because it is 0 here. Since the values that make 0 inside are numbers 1 and greater than 1, a graph is obtained as follows. Let's see this graph if you wish. So let's see for the last time my unit step starts from whatever makes 0 inside, and let's move on the ramp function. For example, if I say A minus 1, what am I waiting for? Now I expect it to start from 1 because the value that makes it 0 will be 1. Let's remember before, let's see again how it was when it was A. Look, it starts shifting from exactly 0. Now if I do it as A minus 1, we will see that it changes from 1, which is the value of makes it 0. As you can see, its value is 1. Why 1? Because he has a 1 in front of him. But let's say something like this is asked. If 2 ut minus 1 were asked, that means their values should be 2 times, but they should start from 1 in the time axis. If you make 2 u step A minus 1 like this, our value will be 2 this time, as you can see, friends. And you initialize the value from 1, not from 0. Now let's move on to the ramp function. I open another script and I will write its function to it. Let's remember the definition of ramp. I will draw this in your signal lesson in your laboratories, etc. If you are doing, I choose it to be useful in MATLAB. RT function is like this, guys. When the function RT is less than 0, it is 0, friends. From 0 it is equal to itself for t, so 1 for 1, 2 for 2. If there were just any number in front of it, like 2 for example, then its slope would increase by a factor of 2. It will be 2 for 1, 4 for 2. Of course, this is a graphical representation. Let's show this RT as a piecewise function. RT equals to 0 for t lower than 0. RT equals to t greater than 0. So if t equals to is equal to 1, if t equals to 2 is equal to 2. This is the most common RT. It is sufficient for us to write this most often in MATLAB. How did I play with the part in the unit step function? Here you can play with the part in the ramp function again. So here it is enough to write the general function or ramp to get the correct results. These functions are not affected in any way with the changes I made later. After all, this is the basic definition. We can manipulate the basic definitions here, guys. After specifying this, use a function like this. Let's return to y's again. Let this be a ramp function. Let my ramp function take an x field into it. I say it should do something about this x field. I prepared that. I will now try to write in it. How do we write this now? Again, I'm creating a for loop. Since I don't know the length of the x period coming from 1, I prepared it as x. I'll try to write this definition later. When it is less than 0, it is 0. Of course, we have to get one of the two equal. Let's take greater equals again. Since it will give exactly 0 at 0, no problem will arise. Let's try to write it this way here. After typing for, here I have to check if. Let's do it like this. I'm checking if. How do I check the if? If the coming x values are less than 0, because they are equal to y, I have to return y again. So here I say that the values of y are equal to the values of xa. So what have I done? I have said RT equals to t. Let RT equals to t, just like this. Let me check what I wrote here. Since I wrote lower than 0, I will use it a little later. I will use it a little later. I'm changing it. It equals to 0 because it is 0 when it's less than 0. Okay? What's the else of this, guys? Its else is directly y equals to xe, guys. Xe. Because if it is not less than 0, something is automatically greater than 0. Therefore, we complete our function in this way. My first end is the if, and my second end is the end of the for, and it was prepared as the end of the function in the third. As I said, the fix here is not function. Y and ramp. Not ramp. If you just say what should be equal to the final output here, you equate the values to them. Here, whatever you want to specify the name of the function, you send it in the program like this, as we did in step. Its ascent is based on this. Let's save this again. Again, the part of the brackets to the right of the equals was immediately perceived as the function name. Let's open a new script, and if you wish, let's copy the previous example. Let's open this first, friends. Now here, I'm sending the result first to the ramp function. Now, here, yes, I'm sending the result first to a ramp function alone. I'm sending a to the ramp now. Here is my expectation from these a values. Before you get the plot, I will do the plot by opening the one I closed. What I expect from this in the conclusion part, for values 0 and less than 0, it is equal to 0. Minus 2 will give minus 1 and 0 to 0. We have accepted greater equals here, but it doesn't matter since it will give 0 again, nothing changes. It will give a value of 0 for the rest, it will give themselves, so I expect it to give values 1.1, 1.2, 2, and 3, and I save this as D16.3, and I'm looking to see if we got it right. Notice guys, I see that they equalize themselves this way for values of -2, -1 and 0 for 0 and remainder. I saw that the result for the A values are equal to themselves for 0 and greater than 0. Of course, the best way to see this is graphics. So let's open these up guys like this. What is my expectation here now? He said go from -3 to 3 in 0.01 steps. So what am I waiting for? This time I expect to see this graph. If you wish, let's run this and take a look at the drawing. As you can see, 1 to 1 will come here. Let's create a grid like this first to confirm the values. For example, let's see it by clicking on it here. 0.5 for 0.5, 0.99 for 0.99. I thought of clicking one here, but why did it show me 0.99? Because this step size has 0.99. Why is there? Because I was able to click on the 0.99 because I went through it in 1/100 steps, and it was one of them at 0.99. If I had made my name there smaller, I could click on the smaller numbers here. So what should I do if I want to double it? If we multiply the othermost of this by 2, you will see that the results that come to 1 now equal 2 times. For example, here is the 1 for 0.5, as you can see now. Look, it looks like a double value for 1 for 0.5x. So does it always have to start as 0? Of course not. When I remove 1 from the ramp in this region, it is no longer from 0. It will start to rise from 1, which makes it 0 inside. As you can see, it started to rise from 1 here. So if I did this 2, where would it rise from? Of course, it would rise from 2 as shown in the figure. And it would rise by 2 times. So let's pick one right here. I'm looking for something we can see clearly. What would you see if we check the slope from here? So from here, this is 2.0. There is 0.1 difference between 2.0 and 2.1. Y is 0.2, base is 0.1, so the slope 0.2/0.1 is the slope 2, that is the value next to the R in this region. That's how we can create the ramp function, guys. We tried to see how the function is written. Hope to meet you in another video. Goodbye.